Hi, the Science Chef is here again. This video is a continuation of our solution to the May-June 2020 Cambridge IGCSE Chemistry Paper 4. Today we will be answering question 3. If you'd like to watch our solutions to questions 1 and 2, we have added the links in the description. So let's start. Question 3. Sulfur dioxide SO2 is used in the manufacture of sulfuric acid. In the first stage of the process, sulfur dioxide is obtained from sulfur-containing ores. Name one of these ores. First off, let's underline the keywords here. Sulfur dioxide, sulfuric acid. Now, this question is on sulfur and its compounds, right? So we should be expecting questions on sulfur, sulfur dioxide, and sulfuric acid. Fine. So now we are asked to do what? We are told that in the first stage of the process of manufacturing sulfuric acid, sulfur dioxide is obtained from sulfur-containing ores, and we are asked to name one of these ores. So first off, what's an ore? An ore is a rock that contains metallic compounds from which the metal can be obtained in commercial quantities, right? A rock that contains metallic compounds from which the metal can be obtained in commercial quantities. We are asked to name one of the ores. Now, not just ores, but sulfur-containing ores. So now, in IG, how do we obtain sulfur dioxide? Sulfur dioxide is obtained by roasting sulfur-containing ores like zinc blende, galena, which contains what? Lead 2 sulfide, or even iron pyrite, which contains iron disulfide, right? By strongly heating any of these ores in in air, right, to obtain the oxide of the metal and sulfur dioxide. If you balance this, it will be 2, this will be 3, this will be 2, and this will be 2, right? So this sulfur dioxide is used in the preparation, in the manufacture of sulfuric acid through the contact process, through the contact process. The commonly used in IG is zinc blende, right? Fine. The next question says the next stage of the process is a reaction which can reach equilibrium, right? The reaction which can reach equilibrium. Let's underline the keyword here, equilibrium, right? Fine. The equation for this stage is as shown on the screen. Fine. Now, what is equilibrium? That's the first thing we should answer. Before we answer this question here, describe the features of an equilibrium. What is an equilibrium? Equilibrium is a stage in which there is no appreciable or observable change or changes in the properties of a system with respect to time. I repeat, equilibrium is a state in which there is no observable or appreciable change or changes in the properties of a system with respect to time. So when a system gets to a point whereby there are no observable changes in its properties with respect to time, then you can see that the system's at equilibrium. So we are told to describe two features of an equilibrium. Now, for a chemical reaction to attain equilibrium, first off, it must be reversible. It must be a reversible reaction. And how will you know a reversible reaction? It is always indicated the equal backward and forward arrows, right? And apart from being a reversible reaction, these equal arrows means that the rate of the forward reaction equals the rate of the backward reaction. Please note, it is not the forward reaction equals the backward reaction. Rather, the rate of the forward reaction equals the rate of the backward reaction. In other words, the rate at which SO2 and oxygen combine to form SO3 is equal to the rate at which SO3 decomposes back to SO2 and O2. Fine. Then the third one is that the concentrations of the what? Of the reactants and products must be what? Constant. Must be constant and not necessarily equal. Remember, we said that equilibrium is a state at which there are no observable or appreciable what changes in the properties of a system with respect to what time. So for there not to be changes in the properties of a system with respect to time means that those properties are what? Constant, right? So which means, and remember, the concentration of the system is a what? Is a property. That's where this point applies. The concentrations of the reactants and products must be what? Constant. They will be constant, but not necessarily what? Equal. Which means that the concentration of the products can be higher than the concentration of the reactants, or reactants can be higher than what? Product at what? Equilibrium. They do not necessarily need to be what? Equal. Fine. But coming back to this question, these first 2 points, this and this, are always accepted, right? The 3 of them are correct, but based on your IG syllabus, always go with the first what? 2 points, except they need more than what? 2. Then you can add what? The third one. So the next question says, name the catalyst used in this what? Stage. First of all, what is the catalyst? A catalyst is a substance that does what? That alters the rate of a chemical what? Reaction. It alters the rate of a chemical reaction and remains what? Quantitatively and qualitatively what? Unchanged at the end of the what? Reaction. Which means that it does not take part in the chemical what? Reaction. It only alters what? The rate, either by increasing the rate or by decreasing what? The rate. And how does it do that? It does so by doing what? By reducing the what? Activation what? Energy of the what? Reaction, or by creating an alternative what? Pathway. Fine. So what do we do here? So for coming to this contact process, right? The conditions for the contact process are temperature. It occurs at a temperature of what? 450 degrees Celsius. A pressure of about between 1 to 3 atm, low pressure, and the catalyst used here is vanadium 5 oxide. Remember, you were asked to what? Name. You were asked to name, not the formula, right? But after naming, if you like, you can add the word formula. And this reaction is an exothermic what? Reaction. It's an exothermic reaction, which means that the change in enthalpy of the reaction will be what? Negative. And why will it be negative? Because the bond breaking energy is what? Less than what? The bond forming what? Energy. The energy required to break the bonds is less than the energy what? Given off when the new bonds are being what? Formed. Okay, so let's move on to the next question. Why do we use this catalyst? Now, there are 2 types of catalysts. We have a positive catalyst or a negative what? Catalyst. A positive catalyst does what? Increases the rate of the chemical reaction, while a negative catalyst decreases the rate of the chemical reaction. So since this is an industrial process and the whole essence is to increase the yield of the product, so we want a positive catalyst will be what? Used. And you see vanadium 5 oxide is a positive catalyst, means that it will increase the rate of the what? Chemical reaction. To increase the rate of the reaction, the rate of the chemical reaction. Next question. Explain in terms of particles why a high temperature increases the rate of this what reaction. High temperature increases the rate of this reaction. Remember, we said that reaction can attain what? Equilibrium. And from our knowledge of the Lechatelet's principle, there are different factors that can affect what? The equilibrium position of a system at what? Equilibrium. And temperature is one of them. Fine. Or change in temperature is one of them. Now, coming to this question, you have to be very, very careful. This question is not on equilibrium position. Rather, it is on what? The rate of what? Reaction. You are told, we know that one of the factors that affect the rate of a reaction is also what? Change in what? Temperature. If you increase the temperature of a reaction, right, the rate of the reaction will also do what? Increase, and vice versa. If you decrease, the rate will also what? Decrease. So that's what they've told you that already in this question, right? And you're not asked to do what? Explain why increasing the temperature will increase the rate of what? Reaction. But don't just explain, you have to explain in terms of what? Particles. And remember, anything that has to do with rate of reaction must always have reference to collision what? Theory. You cannot explain the factors that affect the rate of chemical reaction without making reference to the collision what? Theory. So we are going to use that to answer this question. So now, which property of the system does temperature affect? Which property of the particles does change in temperature affect directly? When you change the temperature of a system, right, it will affect the average kinetic energy of the what? Particles. So an increase in temperature will do what? Will increase the average kinetic energy of the reactant particles. That's one point. Now the next point is that when the average kinetic energy of the reactant particles increases, what will happen to them? They will do what? They will move faster, right? They will move faster and collide more frequently with what? One another. So what then happens here? The particles will do what? Will move faster and collide more frequently with one another. In other words, the frequency of collision between the reactant particles will do what? Will increase. And then lastly, when that happens, what will happen? More particles, more reactant particles will do what? Will acquire sufficient energy to overcome the activation energy. Remember, activation energy is the energy barrier of the what? Reaction, or it is the minimum amount of energy which the reactant particles must do what? Must possess for a reaction to do what? Occur. It can be more than that, right? The energy of the reactant particle can be more than the activation energy, but at least it has to be equal to the activation what? Energy for the reaction to do what? Occur. So more reactant particles will acquire sufficient energy to overcome the activation, and in other words, you have what? More effective what? Collisions. Right. So those are your 3 points. Okay. The next question says, in this stage, only a moderate temperature of 450 degrees Celsius is what? Used. What does this suggest about the forward reaction? What's the qualification of this temperature here? Moderate. And that is not what? High, right? And in equilibrium, high temperature is always used for what? Endothermic what? Reactions, for reactions that love heat, right? Which are endothermic what? Reactions. While moderate or low temperature is always used for what? Exothermic what? Reactions that do not love heat. And exothermic reactions they do what? They react and then give off what? The excess heat to the what? Surrounding. So if only moderate temperature is used for the forward reaction, it means that the forward reaction is what? An exothermic reaction. Okay, then we are now asked to do what? Calculate the percentage by mass of sulfur in sulfur trioxide. Now to calculate percentage by mass of sulfur in sulfur trioxide, right? We're going to use the formula mass of sulfur over molecular mass of sulfur trioxide times what? 100 over what? 1. So let's divide this into 2. Now what's the mass of sulfur? A relative atomic mass of sulfur is what? 32. Well, for this will be 32 plus oxygen is what? 16 from your periodic table. 16 times what? 3. Then times 100 over 1. So from here this will give us 32 over, if you evaluate this, that will be what? 32 plus 48 times 100 over 1, which gives us 32 over what? 80 times 100 over 1. If we evaluate this, you get what? 40%, which means that the percentage by mass of sulfur in sulfur trioxide is 40%. Now, was 40% of sulfur trioxide by mass is what? Sulfur. Now, the next question says, concentrated sulfuric acid is a dehydrating agent which can chemically remove water from substances. Remember, at the beginning I told you that this question is on sulfur and its compound, and because it's on sulfur and its compounds, you should expect questions on sulfur, sulfuric acid, sulfur dioxide. So we just concluded answering questions on sulfur dioxide. Now we are about to answer questions on what? Sulfuric acid. The major properties of sulfuric acids based on your IG syllabus is that it can act as an acid in dilute form, or it can also act as what? As a dehydrating agent in the concentrated form. So let's underline the keyword here, dehydrating what? Agent. And what does the dehydrating agent do? It removes what? Water from substances. And does not just remove water, it removes water what? Chemically from a substance, water molecules from the structure of a what? Of a compound, which means that at the end of the day, that compound can never remain the same. A new substance will be what? Formed, because dehydration is a chemical change. Now, you are told that both hydrated, underline this, hydrated copper 2 sulfate crystals, hydrated copper 2 sulfate crystals, for it to be hydrated, it means it can also be what? Anhydrous. So take note of that. Both hydrated copper 2 sulfate crystals and what? Sucrose can be completely what? Dehydrated. Can be completely, which means that there can also be what? Partial what? Dehydration. Can be completely dehydrated by concentrated sulfuric acid. Name the solid product formed in each case. So here, hydrated copper 2 sulfate. What's the formula for hydrated copper 2 sulfate? That will be CuSO4.5H2O. Right, that's hydrated copper 2 sulfate, which is what? Blue in what color? Blue crystals, right? And now when you react this with, when you add conc H2SO4 here, what will happen? Because this conc H2SO4 has a strong affinity for what? Water. It will remove all the water all the water molecules here to give us what? CuSO4. To give you Cu, what? That's minus 5H2O. To give you CuSO4 white. Now this white is called what? Anhydrous. It is what? Anhydrous. While this one is what? Hydrated. So the hydrated copper 2 sulfate is what? Blue crystals, while the anhydrous copper 2 sulfate is a white what? Powder, right? So they are told to name the solid product that will what form. This is what anhydrous. This is anhydrous copper 2 sulfate. Anhydrous copper 2 sulfate. Name, not the formula. Anhydrous copper. If you don't add this anhydrous, then you'll be wrong, because that's what differentiates it from the word hydrated. Then for sucrose now, sucrose is what C12H22O11, right? C12H22O11. And if we use conc H2SO4 to do what? To remove water from this sucrose, from this compound. Now, how many water molecules, how many H2Os can we get from this compound? If you analyze this carefully, you see that you can get what? 11 what? H2O, because 11 times 2 will give you what? 22 hydrogen atoms, while 11 times 1 will give you 11 oxygen what? Atoms. So when we remove 11 water molecules from this sucrose, all we have left, we'll have what? 12 what? Carbon atoms, right? 12 carbon atoms. And at times this carbon is always known as what? Sugar charcoal. Sugar charcoal. But the answer here is what? Carbon. So this carbon here is always also known as what? Sugar what? Charcoal, which is the purest form of what? Charcoal, right? And this whole process of dehydrating sucrose using concentrated H2SO4 is known as what? Is known as what? Charring of what? Sugar. It's known as what? Charring of sugar. So next, remember, let's go back to this charring of sugar. And I'm not sure charring of sugar is in your syllabus. I'm not sure it's in the IG syllabus. So what you have here is just simple what you have is simple dehydration, which is, so it gives you what? Carbon. But this other charring of sugar and sugar charcoal is just for additional what? Information. Right. The next question says, or the last question says, when propan-1 ore is heated with concentrated sulfuric acid as a catalyst, an unsaturated hydrocarbon of relative molecular mass 42 is formed and one other what? Product. Now let's look at this. Propan-1 ore is heated with conc H2SO4, right, as a catalyst. An unsaturated hydrocarbon of relative molecular mass 42 is formed and one other what? Product. Now what is the term? What is meant by the term unsaturated? Now, first of all, what is a hydrocarbon? From the name, hydrogen and what? Carbon. Hydrocarbon. The organic compounds that contain only carbon and what? Hydrogen. Fine. Now, they can be saturated or unsaturated. Can be saturated or unsaturated. For saturated hydrocarbons contain carbon-carbon single covalent bonds only. We don't have any other carbon-carbon covalent bond apart from the carbon-carbon single covalent bonds. But unsaturated hydrocarbon, apart from the carbon-carbon single covalent bond, they also contain carbon-carbon multiple bonds in their molecules. Those multiple bonds can either be carbon-carbon double bond or carbon-carbon triple bonds, like in the alkenes and what? Alkynes. Saturated hydrocarbons are alkanes, are called alkanes, while these ones can be what? Alkenes or alkynes. Right, so what is meant by the term unsaturated? This means that the compound contains carbon double or triple bond in its molecule. right? Fine. Now write the chemical equation for this reaction. That's for the reaction between propan-1-ol and concentrated what? Sulfuric acid as a catalyst. Fine. Now to form an unsaturated what? Hydrocarbon. Now, first of all, propan-1-ol, which homologous series does it belong to? It belongs to the what? To the alkanols, because of the what? The ol. So it means that to end with what? OH. And what's the general formula for alkanol? That's CnH2n plus 1 OH. And propan, prop here means what? 3. So it means that here N will be what? 3, right? So here it means that this will be what? C3H7OH. If you substitute N as 3 to this equation, right? And if you are using conc H2SO4 as a catalyst, it will appear on top of the word arrow. Now, apart from acting as a catalyst, it also acts as a dehydrating agent, meaning that it will remove water from this one molecule. So if you remove water from this guy here, what will be left? What will have left will be what? C3H6, right? Good. So the chemical equation here is what? C3H7OH, C3H7OH, conc H2SO4 to give us what? C3H6 plus what? H2O. Right? Now you're told to name the unsaturated what? Hydrocarbon. To name the unsaturated hydrocarbon, we need to draw its what? Structure. But before we draw the structure of the unsaturated hydrocarbon, let's draw the structure of the propan-1-ol. 1, 2, 3, C3, right? And OH1 means that it's attached to the first what? Carbon atom, right? Remember, when drawing the structure of organic compounds, carbon will always have one bond, right? While a hydrogen will have, carbon will have 4 bonds, while hydrogen will have 1 bond. Oxygen will have what? 2 bonds. Nitrogen will have what? 3 bonds. So now this carbon here has 2 bonds already. So this one will have, it needs 2 more bonds, which are completed with what? Hydrogen. This one here has 2 bonds already and needs 2 more, completed with what? Hydrogen. This one here has 1 and needs 3 more and completed with hydrogen. So this guy here, oxygen. So oxygen here has 2 bonds, one connected to carbon and the other one connected to what? Hydrogen. That gives us propan-1-ol, right? Now coming to this guy, so to form this C3H6, what will happen? This OH here will be removed and the hydrogen, an adjacent hydrogen, will also what? Be removed. So it means that we have something like this: C, H here, H here, then this bond, this hydrogen, this carbon, right? With these 3 hydrogens here, right? Remember, OH that was attached here has been what? Removed, and the hydrogen that was attached here has also been what? Removed. So the electrons used in forming these other bonds here will now combine together to form the double what? Bond, right? So now what will be the name of this compound? First of all, what's the functional group here? The functional group is what? It's the double bond, which is what? In, right? How many carbon atoms do we have? 1, 2, 3. That's pro. Now what is the position of the double bond? If we move from left to right, this is 1, 2, 3. You see that the double bond is attached to the first carbon atom, right? If we move from right to left, this is 1, 2, 3. Is attached to the second carbon atom. You always go with the lower number. So which is what? That you are going to go with what? 1 prop 1 in. But actually there is nothing like prop 1 in. Propane is propane, because you cannot have prop 2 in. If we change the position of this double bond and bring it down here, to still give us prop 1 in, because if you start labeling or numbering from the right, this carbon that is now 3 will become what? 1. So which means that the name of the compound is what? Propane. So that brings us to the end of question 3. If you learned anything from this tutorial, hit the like button and leave a comment. Also, if this is your first time here, subscribe to our channel and turn on the notification bell to always stay updated with our new uploads. You can also join our membership club to access exclusive videos, live chats, and live tutorials where you can ask questions on any challenging topic in chemistry. A wise man once said, "If you do what is easy, your life will be hard. If you do what is hard, your life will be easy." So keep facing your challenges till I see you when I'll see you.